All right, here's 1.3. 1.3 is a very short lesson, so we'll get in, we'll get out, and be on our way. However, it's important because it talks about simple random sampling. And simple random sampling, while being very basic, is used in a lot of the other sampling techniques. So it's the basis of how we get a good sample. Um, in order to have a simple random sample, the first thing you need is a frame. A frame is a list of everyone in your population. So that means in order to get a good sample, you need to know every single person that's in your population. Um, the idea is if my class, so all of you, there's 66 of you, I believe, 65, something like that. So I have 65 students. I'm going to randomly give out 10 bonus points to 3 of them. In order for this to be a fair sample or a fair type of thing, I need to make sure that when I'm choosing a random name, that I have all of your names available to choose from. If I have 65 students, but I only have 30 names that I'm going to choose from, well, that's not a fair sample. Those 35 other students whose name I don't have aren't going to have an equal chance of getting picked. And so because of that, that's why we need that frame. In order to have a good sample, everyone in the population must be available for me to choose from. And so for most of our sampling techniques, you're going to have a frame. Random sampling is simply the most basic way of randomly choosing something. The most common example is you write everyone's name in a hat or on a piece of paper, and then you put all of those into a hat or into a bowl, and then you stick your hand in, swirl it around, and pick a name. That's a simple random sample. If you do that 10 times, you get a random sample. So that's the idea behind a simple random sample. You have everyone's name as an option, and then you go through and you can either do names from a hat, or you can use a random number generator to pick a random number, and then you look to see which student is assigned to that number. And that's a simple random sample. So very basic, very quick, very easy way of getting a sample. So now that we do that, we're going to talk about some probabilities of things happening from that sample. So read this example and go ahead and try and answer question A and question B. So it says a psychologist who leads a brain tumor support group wishes to meet one-on-one with two of the 8 members to evaluate the effectiveness of the group. It then lists all 8 people, and it wants you to list all of the possible pairs for this 2 one-on-one meetings. And then for part B, it wants you to comment, so give me the likelihood of Alex and Grant being the pair of people that are selected for those 2 one-on-one meetings. So pause the video and then do those 2 things. All right, so first, coming up with a list of all possibilities. Well, when we go through and do this, if you notice, these names were chosen for a very good reason, and that is that they're in alphabetical order. So I'm going to use the first initial to represent each person, so I don't have to do quite as much writing. I'm going to go through and say, okay, well, the first group could be Alex and Brittany. Then Alex and Caleb, Alex and Dave, Alex and Edward, Alex and Frank, Alex and Grant, Alex and Heather. So there's 7 possible groups. Next, I'm going to go down, and instead of starting with Alex, I'm now going to start with Brittany and all the possible connections that she could have. Now, one thing to remember is we already have A and B, so B and A is not needed. It says do not duplicate pairs. Alex and Brittany is the same as Brittany and Alex. So we're not going to duplicate that answer, which means we're going to start out with Brittany and Caleb. And then Brittany and Dave, Brittany and Edward, Brittany Frank, Brittany Grant, Brittany Heather. And we're going to continue doing this for all of our examples. So Caleb and Dave, Caleb and Edward, Caleb and Frank. And that is all of them. And if you notice, none of them start with Heather because Heather's already been paired up with all of the other people as we've gone through. So we've created a list. How many possible groupings or pairings are there? There are 28. Now the question is, what is the likelihood that Alex and Grant are the pair picked? Well, in order to do a likelihood is essentially a probability. We need to look to see how many ways Alex and Grant can get picked and divide that by the number of possibilities for that pairing. So go to our list of 28 pairs. How many of those pairs consist of Alex and Grant? 1. There's only one group that is Alex and Grant, and that's the Alex and Grant group. It says not to duplicate, so there's only one. Next, well, how many total pairings are there? How many different options are there? And there's 28. So the likelihood of Alex and Grant being selected is 1 out of 28. Next, this last section, it talks about a random number generator. We won't be dealing much with a random number generator. There are random number generators on your calculator. If you have a TI graphing calculator, they have random number generators. There's random number generators all over the internet. And while they're not truly random, they're not 100% random, they are very, very close to being random. And that's a much nicer thing than what I used to have to use. When I was in college, not everyone had a graphing calculator. And so instead of using technology to come up with a random number, we were given a random number sheet. That was a sheet of numbers. So just an 8.5 by 11 piece of paper that had numbers printed all over it. And we would use that as our random number generator. You'd put the piece of paper down, put your pencil above it, randomly drop your pencil, whatever number it hit. That was like your starting random number. And if you needed more than one, you just started moving down rows on that piece of paper to find however many random numbers you needed. Technology has come a long way. We have much better random number generators than that now. That is the end of 1.3.